Chapter 6 is about composition of substances and solutions. If you have put your calculators away, go ahead and get them back out because we're going to be using them extensively in Chapter 6 and 7. In Chapter 2, we talked about molar mass. Now I'd like to describe a few related concepts. For mass of a single covalent molecule, we can use either the term molecular mass or formula mass. The units we would use for mass of a single molecule would be atomic mass units, or AMU. Molecular mass specifically refers to molecules, and formula mass would be the mass based on the chemical formula. For ionic compounds, there are no individual molecules, so the term molecular mass would be inappropriate. Instead, we would use the term formula mass, which would be based on the chemical formula of the ionic compound. If we want to use a larger scale, we can use the term molar mass, and the units on that would be grams per mole. Whether we use the term molecular mass, formula mass, or molar mass, we go about our calculations the same way. We take each of the elements' masses from the periodic table and add them up. For example, for CHCl3, we would have 1 times the mass of carbon plus 1 times the mass of hydrogen plus 3 times the mass of chlorine from the periodic table, and add them up. To find the molecular mass of aspirin, which is C9H8O4, all we have to do is take 9 times the mass of carbon plus 8 times the mass of hydrogen plus 4 times the mass of oxygen from the periodic table, and add them up. As you do these types of problems, use the full mass on the periodic table that's in front of you, whether it be the periodic table provided on your exam or the periodic table provided by WebAssign as you're doing your homework problems. We can also find a mass of an ionic compound such as aluminum sulfate. Aluminum sulfate has the formula Al2(SO4)3. So this formula tells us that there are 2 aluminum ions for every 3 sulfate ions. 1 formula unit of aluminum sulfate will contain 2 aluminums and 3 sulfates. But remember that ionic compounds are 3-dimensional arrays of ions. There would be many more than just 2 aluminum ions and many more than just 3 sulfate ions in a sample. We still go about the calculation in the same way. But remember, when we have parentheses, the subscript on the outside of the parentheses gets multiplied by the subscripts on the inside of the parentheses to tell you how many of each type of atom you have. For aluminum sulfate, we would have 2 aluminums, 3 sulfurs, and 12 oxygens. To calculate its formula mass, we would take all of those masses from the periodic table and add them up. Notice that the figure from your textbook says molecular mass, but that would be inappropriate for an ionic compound. It really should say formula mass.